So I'm going to give a talk today on scaling security with DevOps in mind. I believe, I didn't make the earlier sessions in this room, but I believe there was a lot of DevOps definition talks, and so so I looked at that and decided I'm a late addition, so I was able to see the schedule before I said what I was going to talk about. I decided to just kind of skip all that, assume you know the basics of DevOps, and talk about how security plays into that, because that's something that I've been hearing a lot more of in the past, I'd say 2 years. HashiCorp has been selling what categorized sort of as DevOps tools for, I guess, almost 5 years now. So I've been having a lot of conversations with companies about DevOps for a reasonably long time while the company's been incorporated, and for a couple years prior to that. I've noticed a noticeable shift in the past 2 years of the conversation moving from CIOs that generally are like, well, we have a lot of material that's going to get us to the benefits of DevOps, and we feel pretty confident about that. And now the big question is, how do we bring along some of these other teams? And the one that's really been hitting top priority recently has been security. So I want to talk about security. I got a good introduction. If you want to find me on Twitter to message me or ask me a question, you could do so there. As I said, I'm one of the founders and co-CTOs of HashiCorp. We make these tools, which I just put up here. I'm not going to talk about pretty much any of them except Vault. And I'm going to use Vault as an example, but what I'm going to talk about is more abstract than that. So it's not supposed to be a Vault pitch by any means. It's more about what are modern security practices that could be used with DevOps. So let's just go ahead and get started. If you want to catch me after this and ask me about anything else, you're free to do that. So let's go ahead and get started. And the first thing to break it down is to just talk about scaling and what I mean by scaling. And when I talk about scaling in this sense, I actually mean both people scaling as well as what I think tech people normally think about when they think of scaling, which is more like infrastructure and applications. So I'm talking about scaling as well as your company grows. So your company is growing. When you're 2 people, you either do very little security, or you care a lot about security and you could really focus on it. But as your company grows, it becomes harder and harder for everybody to share that same mindset, and so that becomes a challenge. And then on the right side, the little computer screens, is both infrastructure scaling, which is obvious as you get bigger hardware, more hardware, but also application scaling is in the number of applications. As your organization grows, you usually add more applications. If you adopt the microservices mindset, then you may be adding order of magnitude or more applications right now, and that's also introducing new security challenges within organizations. So I'm going to cover both of these. So here's I guess it's like an antithesis diagram for DevOps, but historically you would do developer, throw something to an operator, throw something into production and watches it. DevOps, or however you want to call it, has been trying to move to this model where developers are empowered to do more. And I'm sure people covered before that it's not about developers becoming operators, or they're the same person or have the same concerns necessarily. It's just being able to do more in parallel in order to deliver value faster. And that could mean delivering updates faster, delivering more applications, etc. And during this process, security has been a little bit of a question mark. For a lot of companies, it looks like this. There's a bottleneck in there with security. You're not quite sure how it works. And so a lot of people have been asking sort of, what do we do about this security problem? And in about a year ago, there was one particular meeting that stood out as particularly, I would say, entertaining for me, but probably not for the other side. I was visiting a couple C-level executives at one of the largest banks in London, and our salespeople were kind of going through their normal pitch, so to speak, in this meeting, and the CIO stopped and said, look, we just don't care about deploying faster. We don't care. And they're like, we could deploy once a week. And that's slow by DevOps standards, but we don't care because when we build a new application, it takes 2 months to get through security review to get to production. That's the problem. We don't care about faster deploys of existing applications. And so that was good. It shifted the conversation over to our Vault stuff and how we can maybe help them. And I'll give you an update on that a little bit later. But that's sort of like what the worldview of what's happening here is how do we sort of remove some of this bottleneck here around security, if that is one. If you don't have security people at all, how can you start thinking more securely and bringing more security into our organization while still moving fast? So there's basically only 3 ways to scale anything. If you need to scale anything, you could do less of that thing, you could do that thing faster, or you could do more of that thing in parallel. These aren't mutually exclusive. Sometimes you could do multiple of these things and get bigger wins, but this is pretty much exclusively the only 3 ways to make something scale. And so in a security mindset, I argue that you don't really want to do number 1. If you assume that doing less security is worse in general, then you're stuck with number 2 and number 3. We need to do security, and I'm saying do security, which is actually kind of a weird way to say something, but I'll say that a lot during this talk and just assume it to mean that building more secure systems, understanding, being able to detect breaches better, the whole sort of ecosystem of security. So I argue number 2 and 3. You want to be able to do security faster, and you want to have more people be able to do it in parallel. So the core question becomes basically how do you empower people to build secure systems? And this is interesting because this is, I'm sure, a sentence like this, I made this talk like 2 months ago, and I'm sure a sentence like this showed up sometime earlier today because one of the core questions of DevOps has been how do you empower people to participate more in operations, or how do you empower people to collaborate more? And what's interesting about scaling security is it pretty much boils down to the same thing, which is how do you empower people to build more secure systems? And so with that critical question in mind, I break down empowering people into 3 groups of people. And I'm not trying to silo people off here, but these are general personas of people. If they meld together in your organization, fine. If they're separate, in a lot of companies they're still separate, which is fine, then this is how I break it down. There's basically 3 groups of people that need to be very intimately involved with security during the process, and they each need different things to be empowered. For developers, that's just an API. You give developers an API, and pretty magical things happen. Like that's what developers do. And developers aren't supposed to be field level experts in any specific topic. Like if you look today, machine learning is a very hot thing, and more developers are doing machine learning. And I would argue that like 95% of them, and me included, are not machine learning experts, but they're able to do it because the APIs are getting higher and higher level, so that building basic recommender systems or image recognition or things like that is at the fingertips of a very surface level person, which is perfect. That's how it should be. Security needs to be the same way. There needs to be APIs where developers are not security experts. It's a lot to ask a developer to be an expert in security, and instead they have an API available where they could build secure systems without being that expert. For operators, operators value things that aren't weird. Operators value repeatability and understandability. So you want to be able to give operators the ability to build secure systems without breaking their worldview, fitting into existing tools that they're already comfortable with, fitting into existing monitoring, logging, deployment systems that they're familiar with. Things like, I think I get into it, but things like hardware devices aren't great for operators because it's just a snowflake in your data center, and especially in this sort of day and age, we're trying to get rid of the snowflakes. We're trying to make everything look kind of the same. And then the last people are security engineers. Security engineers are amazing people because they dedicate their career to just thinking about how they could be totally screwed and how to protect against that. and so these people, you want to be able to give them the answers to those questions. You want to be able to give them clear threat models. You're telling me this makes me secure, but where does it make me secure and where does it not make me secure? Don't give me the marketing crap. I need to build a threat model. You need to tell me where I need to fill in the holes. They want strict usage controls. Every company has snowflake reasons for allowing certain people to do certain things, and so you need to be able to give people the ability to just let them do what their organization needs to do. And then they need auditing. Auditing is super important because security always boils down to scale. Security will always boil down to a trust but verify system. You can't just give someone full trust to build a secure system and hope that they follow through. You trust that they follow through, but periodically you need to audit that behavior, and so they need a way to be able to do that. So Vault is an open source free project we have that handles one aspect of security. It does secrets management, certificates, encryption, some other things. I'm going to use it as an example of how we approach some of these needs. And like I said, it is not meant to be a pitch for this software. It's just meant as an example for how we do it. But you should be able to hold pretty much any software, any practice to these standards. And then after I get through the technical stuff, we're going to get into people responsibilities and how people work together. So for Vault, here's how we do each of these three things. So developers, like I said, need an API for security. What Vault gives you is a JSON API over HTTP over TLS, which today is a very, very standard API. Any developer sees that and they have 1,000 tools that they could use, maybe not 1,000, but 100 tools they could use to slice and dice that API however they want. You could integrate it into any modern web application, no matter what language that's written in. It's easy to use. It's funny because there's a lot of legacy, I'll call them legacy, security systems out there that if they only did this first bullet point, I think they would just get way more adoption in this new cloud migration world. There's other issues which I get to, but I think this is a big one. When we were looking at some other solutions, there's so many weird APIs out there, and they're weird for good reasons, but not good enough to be the only way to interact with that thing. Like HSM's a standard way of interacting with an HSM is via SSH using this weird key exchange thing, and there's just no way that you're going to get multiple applications to interact with that thing if you need to do that sort of the dance to get your secrets. The three APIs, so there's a lot that Vault could do, but the three major reasons people adopt it are these APIs that we provide to developers as high-level APIs. There's secret storage. This is answering the question of, I have something secret, I'm pretty sure the database isn't the right place for me to put it, but where should I put the secret thing? Vault will store it for you, don't worry about it. Encryption services. This is a pretty big issue for So developers are pretty good about passwords. There's so many times where I've seen a database, or a schema of a database, and it's like the password has the hash, it has a salt. Good job. Hoping you chose the right hashing, probably, so good job. But then all of a sudden next to it I see like first name, last name, secret question 1, secret question 2, secret answer 1. And are those all plain text? Like, if those are all plain text, you might as well not hash the password, because if you could get into that database, you could social hack enough to get access to other systems. It's really not, you don't need the password. The password is not the way you compromise accounts these days. So I want the mother's maiden name and things like that. That gets me way more leverage. And so encryption services, you want developers to be able to say, I have this data, I should probably encrypt it. How do I encrypt it? And Vault just gives you an API endpoint. Send me the plain text here, I send you ciphertext back, store it. And Vault handles the hard questions like key rotation, key hierarchies, access policies, audit trails, that sort of thing. The things that security engineers, as I'll get to, are going to want to care about. The issue with encrypting locally in an application is you lose that sort of stuff. For example, a very large company uses Vault to do end-to-end encryption of chat messages that are probably on a lot of your phones. And what's interesting is they need to rotate the key every day, because if they get a breach, they need to make sure that only their SLA is that only up to 24 hours of messages can be decrypted with a lost key at any given time. And so they need to not only rotate the key, but they need to keep all the prior keys active, because it's too expensive. It's petabytes of data, and they can't decrypt. They can't re-encrypt all that data. It just would never complete. And so you could either build all that by hand and give it to a security engineer to build it all by hand into the application, or you could just have a repeatable JSON API-driven way to do that in any application. And so that's sort of what happens. And then the last thing is certificates. Because of things like Let's Encrypt, we're doing a great job of having certs, public-facing certs on a lot of websites. That really hasn't translated yet very well in internal service communication. So between applications, there's still a lot of plain text connections. And I think that boils down to just dealing with certificates is hard. Running your own CA is kind of a series of magic incantation with OpenSSL, and then figuring out, again, all the policy around it is hard. We give you a JSON API for give me a certificate, verify a certificate, that sort of stuff. I forgot I have examples in this one. Here's like kind of a basic example. I think there's only 4 slides of these, so I'll just run through it fast. But here's like how you would store a secret. You just send JSON to an endpoint. You could request it back, and you get it back. There's some other fields there that I'm not going to go into in this talk, because not of all talk. What is this? This is the encryption endpoint. So here's how you encrypt something. You send plain text, you get back some sort of encrypted thing. Yeah, and like I said, there's only a couple examples. But the point is that they're really easy to use APIs. You just curl them. All our training programs just use curl because it's so easy. Okay, for operators, we just provide software. So there's no hardware requirement for Vault. It does integrate with hardware things, but there's no hardware requirement. It's pure software. It is stateless, so it doesn't store data on its own. It uses data stores in the back to store encrypted data, and it doesn't trust those things. So it assumes that those things could be tampered with and could detect that, but it's completely stateless on its own, which makes deploying it really, really easy. It has active standby, HA built in, and that's really important with clouds, because a lot of other security software basically gives you single master and says if this goes down, you lose access to your passwords. And that doesn't really jive well in a cloud world because, again, it's a snowflake and a very hard SLA to keep in something like AWS. And then there's read scalability capabilities. And then for security engineers, Vault has this model that's the Fort Knox model. There's a saying in security, which is put all your eggs in one basket and put that basket in Fort Knox. It's the idea that you should do security exceptionally well in one location rather than try to duplicate that level of security across multiple locations. It's interesting because it's a little bit counterintuitive. You think that you should kind of spread things out and secure them in different places to prevent breaches. But the best practices that we found getting Vault into these companies is that they want to centralize everything because they'd rather lock that down like there's aliens in Area 51 in there and then protect it all right there. So there's a few ways to do this. We have n-person operations on Vault, so you can define different endpoints to require n people with access to be able to make that thing happen. And so you generally need n complicit individuals to do a bad thing if it's something is secure enough. There's audit trails built into everything. There's even reconfiguring parts of Vault. There's nothing you could do to Vault, literally nothing you could do to Vault that doesn't go into the audit log. If Vault fails to write to the audit log, it does shut down. It cannot operate without a writable audit log. And you could set multiple, so you could also detect whether an audit log has been tampered by sending to 3 different locations. That one could be Splunk, one could be a file, one could be a syslog. They could be totally different. And that's very common for operators to have access to some cluster, but security engineers have their own lockdown installation that nobody else gets access to for audit logs that you could corroborate stuff. So audit trails, access control into anything, you could access control anything in Vault. And then there's a clearly defined threat model architecture. If you go to Vault's website, we tell you what we protect against and what we don't. Like for example, one thing we don't protect against is a memory dump. If someone gains root access to your machine and they're able to dump the memory of Vault, you should consider your master keys lost at that point. It's possible. We try to make sure they're not in memory at any given time. We do our best, but it's not part of the threat model. So you could be in trouble, and you should go through your procedures as if that was a full breach if that happened. Then the last thing, it's open source, which makes it very transparent about what's going on. It's audited by a lot of third parties at this point. We run a couple audit firms every other release, but the people who have adopted Vault also independently often run audits and report the results back to us. So there's that. We hit a lot of compliance things, so Vault's used in Fed, in healthcare, and education. So we hit a lot of the necessary requirements for compliance that people need. And I don't know what I meant by feature support there. I don't know. So okay, so those are like a ton of technical stuff. That's like the technical part of building, I think, a modern security tool. If I were using something that provided secrets today or provided encryption today, I would request JSON APIs. I would request audit logging and everything. I would request audit logging to standard software. Like, I want to put my audit log in this SaaS that I use, which it sounds like, again, you're breaking down some level of security there, so can I send it to multiple places? There's things like that. These are just patterns in software that you could try to get, and hopefully why they're important. So then the next part I want to talk about is the people side of how do you use this sort of technology to actually help your organization go faster. So this is the goal, right? Like, we want this to happen. But realistically, it's not like security, it's not like developers and operators are just like, not my problem, security's got this, and going full speed while security's also going full speed. You need some level of security mindedness in every single level. And so this actually breaks down usually to these people being responsible for different levels of security. And I'm going to go bottom up because that's easier, unless these slides, yeah, they go bottom up, good. So I'm going to go bottom up because it's easier to go like really big picture and to really specifics that way. So security engineers at the bottom, like I said, like heroes at the bottom, they should be thinking about big picture security. They should be thinking of sort of the allowed protocols, the key hierarchy, the process, the people process involved with security in addition to the technical decisions. I like to describe security as an endless turtle tower. Like, as soon as you answer one question in security, the next question is how do you secure that? And that just goes pretty much forever. And for every company, it's interesting because that last turtle where they finally are like, oh yeah, we're secure now, is totally different. And if you're at any turtle above that, it's completely binary. It's like if you go to a company and you don't hit the turtle they want to hit, they're like, this is the most insecure thing I've ever seen. And then you hit that turtle and suddenly it's like, we're rock solid, we're good to go. And so it's pretty funny. But these security engineers are actually the people that decide which turtle they're going to live at. And so you want to let them figure that out. You want to let them say that, no, we can't encrypt unless we have key rotate. We are able to key rotate every single thing that's encrypted. You want to have them make those decisions, and that's what they're doing down here. In addition to that, they're also doing periodic audits of the layers above. And so this will be a common pattern, but trust but verify at every step. You're releasing a lot of responsibilities upwards in this layer that I show you. But at the same time, you're periodically auditing the system to make sure that they're adhering to what you'd like to happen. Then you have ops people above that. Ops people are caring about infrastructure and network security mostly. They're deciding more or less, working again with security engineers, but more or less the layout of the data center, layout of the network, setting up rules and things like routers and switches to prevent non-compliant behavior. They're building safeguards in here and then delegating more to developers. So yeah, I sort of got this all in here. Things like OS security, file permissions, how deployments happen and how they could happen in a way that is secure for security people. But again, these policies are sort of, they're shared among them all, and there's a trust system that they're just going to do it. There's not a synchronous check at every point that they're in compliance, basically. And then the last tier up is developers, and they should be caring about application and data security at the very top. Data security in terms of when the data comes in, am I handling it in a secure fashion? The ops people are more concerned with, once the data's on disk, am I handling it in a secure fashion or persisted somewhere? But developers are generally thinking, am I talking to the world with a TLS connection? Am I talking to the services I need to with a TLS connection? Is there a point at which the data becomes unencrypted? What is that point? Is that okay? They're making the decision of, I just got in some data. Should I encrypt this? Should I store this in Vault? Does it require a higher level of security where I don't even want to put an encrypted value in our own database? Like, where should I cross these boundaries? Developers should be able to make those decisions. You're not you're not relying on developers to know what encryption algorithm to use. You're not requiring them to know what key sizes or where they're storing the key or how people get access to the key. Those are hard questions that they're capable of doing, but it's not for their job function. It shouldn't be necessary. And so you're just giving them you have all those tools, make the right decisions. Yeah. And so at every level there's a trust but verify, and I've said this multiple times, but for developers there's both like system level verifications, which is that maybe your routers just don't allow non-TLS traffic through. Like they just can't make a non-TLS connection. That's a like hard verification that's going to actively deny something. But there's probably also pull review. All right, pull request review. Developers use pull requests to review logical correctness in code, stylistic correctness. They should also be using pull review to ensure security correctness of their code. At the ops layer, the verification is, like I said, at the switch layer, but then the security engineers often get access to things that ops are doing in a separate location that ops won't have access to. And that's okay. It's just usually audit information that they're going to use to go back in time to look for weird behavior, basically. And there's a variety of tools that could look at actually Vault audit logs today and try to find sort of anomalous behavior, things that don't look quite right, and that should happen. And then at the security layer, they're kind of the last turtle in the tower for your company. I mean, I think if a majority of the security engineers in your company are out to get you, they're probably going to get you. In terms of the U.S. government, sometimes it just takes one person, right? And so like you got to trust your security engineers to build the right policies and do the right thing and have the company adhere to that sort of mantra. So there's these layers. So going back to that one company that had a 2-month security review, so they started going through with this sort of thing, and they're not at the point where it's full-blown, but the thing they did, to just give you a concrete example, is they broke down their security team to actually start embedding one security engineer for N applications. I think it's around 4. So for every 4 application teams, there's one dedicated security engineer. There's still a core like security team, and they're trying to do the big picture stuff. The core security team does pass audits, but they don't actually do they don't block releases anymore. They're trusting the security engineers embedded on the teams, 2 security engineers per 4, but they're trusting the security engineers embedded on the teams to be adhering to the big picture policy that the core security is building, and they're hoping that, and it's a big education thing, it's a big company, so they're educating more and more to get ops and dev people doing more security, but it's already helped a lot. So they've already gotten down their 2-month review cycles down into 1 week. So they're about the same cadence of deploys, which is a big win for them. So that's an example for them, and that's sort of the end of my talk. So thank you.
Thank you. Nicely done on the time. Okay. Everyone's so good here. Unlike me. Thanks for that talk. Any questions? Anyone on that? Yes?
Just your Fort Knox example. In a globally distributed world, right, where we have instances.
Yep.
What I said, globally distributed. How do you maintain the metaphor of a centralized Fort Knox?
That's a good question. The answer is a very overloaded word, which is federation. So it's kind of, so basically the pattern we see is that there's still a central leader master vault cluster that maintains the rules and the policies and access control and the auditing rules, like, and all that sort of thing. But then the region local or data center local secrets and stuff are actually stored per data center. So you do distribute secret information, but there is one central place that's saying it doesn't matter what kind of data center you are, to get auth information, auth access and things like that, you need to be auditing to this type of location, this sort of thing. And so there's a central policy, yeah, and then distributed data. So it breaks down a little bit, but yeah, I mean, if you're like, for example, if you're hitting Vault to encrypt data, you're not paying a WAN fee on every encryption. You want to be able to hit it local. So yeah, yep.
Just generally, I'm curious, is everyone, I mean, is this resonated with everyone, that kind of security being the one that stops that automation? seeing a lot of nodding heads right now. I've been to a lot of meetings, in-custom meetings, and they go round the room, and it's amazing how it's evolved. I mean, I used to just go in and be like network architects, and then it evolved to network and app and data center architects. And then still though, the security architects don't get invited to the meeting, because within that organization they're like, but then we can't go live. So there's this battle does it sound like pretty much everyone, yeah.
It's not like I mean, historically it wasn't a good idea, but you could kind of leave them out before, because you could have this castle and moat analogy, where you had the security people like literally like, you know, building the walls around everything that was safe inside. But when you're moving to the cloud, I mean, you're one line of software bug away from someone just like flying into the middle of your secure network. So, yeah.
And the theme of today has been a lot about this cultural change, and that's a big part of that, breaking down those barriers. We just can't be successful continuing to have these silos. So, yeah, that was awesome talk. Thank you very much.
Thank you. Thanks.
Mitchell, is there any other questions?
Yes. Yeah, I have a question. So you mentioned that various companies have the kernels and the chain of trust down to one thing that is the root of their trust. I was wondering if you could give a couple examples of different roots of trust that you see in various companies.
Yeah, they vary pretty wide. I mean, I think a good example is like a lot of startups will just say that, you know, we're decrypting our passwords and we're using TLS connections externally. We're good, like we're reasonably protected. And depending on your app, that might be true, like it might not matter. But then there's other companies like the communications app where they couldn't adopt like an encryption model without having 24-hour infinite life key rotation. That's just a requirement. And so it's really drastic, and it's also really dramatic. It's as someone who like, we have a Vault team now. I don't work on Vault as closely, but as someone who has, it's very frustrating because security people are also pretty vocal. And so you get a lot of people that, like I said, it's very binary. And so you just get a lot of people that will totally tear apart your software pitch or whatever because it just doesn't happen to hit their turtle, disregarding that maybe other people's needs are very different.
Another question?
Taking that a little further at a tactical turtle, I guess.
Loving all the turtles. Like.
With Vault, right, I'm just getting that service authentication. What are you using for that, and where are you storing that, right? Whether that's a token within there or a certificate,
yes.
Whatever, just the whole.
How do you auth to Vault, basically?
Yeah.
Oh yeah.
There's a turtle.
Yeah, actually it's a really good turtle, because that's one that's very common. So that's one that's very common, which is like, what's the point of adopting Vault when the secret to authenticate to Vault sucks to secure? We've been working in a lot of different ways to do that. One of the common things we found is that a lot of companies going into cloud have to some layer trust the cloud control plane. If you don't trust the cloud control plane, they could be injecting data into your VMs. They could be screwing around with, you know, the host system could be insecure. There has to be some level of trust for the cloud service provider. And so one of the things we've done, and it's optional, there's people that don't trust the cloud service provider, which is an especially interesting but also sad world to live in, but possible, totally possible, just workflow difficult. But one of the things Vault could do is we have integrations with Google and Amazon, and I think we're working with Microsoft right now, but Google and Amazon, where they provide an API where as long as that instance has the right metadata associated with it, whether that's tags or a subnet location or a security group. Yep, we associate that with some implicit rule auth in Vault, and so when your application starts up, you get access to that.
Folks on-prem, or are they going more just hardware route on there?
That's right. That's right. That's right. And we have, I mean, you could try to do that model also in the cloud world too. So there's people that do that in the cloud world, which is that when it starts, someone has to get a second factor basically into the app, into the instance somehow.
We've got a room full of
we give you we give you options on your turtle.
That's cool.
So I'm not saying that blockchain is the solution for everything, but the purpose of logs, is that actually an applicable use? Because it seems like having distributed logging, so it might actually be a way to avoid tampering.
Maybe Maybe, if it's fast enough, I guess. So the autolog has to be able to persist fast enough at the same request flow that Vault's getting, equal or greater, right? And so it has to be fast enough. I think you get enough security by being able to go to n duplicate sources, and then we HMAC every single individual entry. So you actually have integrity checks on every single individual entry. So there's a lot of layers there to help protect you.
Cool. We're kind of at the end of our time now. I hope this has been really useful for everyone. Has it been useful? Good track? See, you're glad you came to this one instead of going to the AI one? Tried to chick you away?
You got tactical turtles?
I loved all the turtle stuff. That was like the best bit.